we still record it today. About this Rembg, remove the background of this project, because I use it 3 to 5 times a day. 10 times I found this frequency is too high, and it's not very convenient. And let's take a look. The method I use is the method of using this CPU. Because my GPU is P106100, its older chip architecture does not support. And then, the way I do it is to use the default method. It's this RGBI, then the picture I have to process, and the picture to be output. Here it is. It is handled every time with the command line. It would be super troublesome. For example, I will open this interface and create a virtual environment. Enter the command just now on this line, then manually find my picture, then find the picture I output. This is super troublesome. And let's take a look. You have to know this one thing that seems to be successful. We have to test many times. The plan I started with was this Orange Pi 3B. 8 GB, its performance is equivalent to the Raspberry Pi 4B. I use Python's virtual environment, deploy it at Linux endpoint. I haven't made it into an API yet, or in the form of GUI. I tested it first. One is about 30 KB. This is a compressed image. It's about 100 times 60. It takes 30 seconds to process. Then if you say more than 800 kilobytes, it's still the same picture, uncompressed. It takes about a little over a minute to process. This is unacceptable to me. It's too slow. The second one, I use this 35% 3B or Sumerian enhancer or something like that. After the test, I used this x86 small host to test. I found that he still doesn't is the effect I want, because his performance is still a little worse than that. For example, 20 seconds to process I did not deploy due to some network dependency issues. I'm not in the mood to deploy this. Then I came up with several reliable solutions. Keep looking. Let's look at this computer. The first thing that came to my mind was the Python GUI. That is, Python, PyQt, or other frameworks. Then he is direct. You can open exa on Windows. Then drag and drop the picture to process. The entire environment and the entire process are integrated, but the only price is his volume is relatively large. Let's say it's about 1 trillion or 2. Then you need additional learning and development costs. I asked AI, even with the help of AI, I also need about 3 to 5 days to make this program. I don't think it's worth it, because I don't have that much time. And the second thing that came to mind was, with this electric, the front and back ends can be separated. Go and package it into this Windows Ease. So my front end can still use this desktop offline. Then the back end changes the Rembg to the form of HTTP ABI, so you can use it directly. But for now, this selection is more friendly to this load support. Python needs to get another process, separate again. It's not a very good grand scheme. Therefore, this plan is also temporarily ruled out. Then the third option is, for example, let's make it an external interface. Make an external interface. Then we click Upload Picture. For example, let's take a look now. Let's take a look at this picture. I expected this. He can click in the browser with this choice, or drag and drop the picture. Then, after we click, select this picture we want to process. After selecting, click Deal here. After processing, we get what we want. Remove the background. Preserve portraits to download. But this thing, you need to develop an external one separately, and I'm going to make it into one. What makes this an HTTP service? And then, if you think about it being networked, if I call to the local picture, This internet speed will be the key to his speed. I'll handle it in 5 seconds, 10 seconds or something. But over the network, for example, a picture of 3 trillion, 10 trillion, it might take 20 or 30 seconds to send it back again. I don't think it's worth it either. So my final solution is to use this. This is the stable division of the web UI. Then let's open it here and take a look. He doesn't have to think about X1 here. Don't think about anything else. Hold on. He just opens this stable. Find this right-hand point back. Then he'll start a back endpoint. After the endpoint, start a local host. All your processing of this picture of this API will go through this external interface. Then go to this local call. This way, I save the processing of the network. But he also needs to use this external UI. So I now have an advantage to my plan. What is it? The way I use this bat, call the local host, call the local HTTP, then I give my code with bad GPT. Then the plan I choose is very important. Python's FastAPI. Let's take a look. For example, we use this master API to. This framework is modernizing an API. Then support asynchronous programming. And there is a very good ecology. What's the most important thing? Because what is ours called? IEMBG. It was originally Python, so it is integrated with the Python framework. We don't need an open process. Use this command line directly. Handle the Python code it provides. Then let's start the service. The advantage of using this framework is that we click on this to start the service. You can see it here. And then we provide a default document ourselves. For our box. What's one advantage of this Swift documentation? We click on this interface. Click to have a try. It will come out a fail. If it fails, there is an execution. We click to select file. Click on this picture where I want to remove the background. Double click and then we hit execute. You can see it here. It generates an image with the background removed. Then right click, you can save or copy the picture. So what's the benefit of saying that? First, I don't have to study alone. This Python GUA framework, ESE, it takes 7 days. I have also been a front-end programmer for 10 years. I don't have to bridge this project with Electric and this Python. The two of them are not a unified ESE. Then I'm too lazy to write a separate code. So I'll do it the local way. Use this method with reference to this stable defacement. Then open localhost access the local. However, you still have to write the external interface yourself. So here's a coincidence. It's me who is using this latest API. The shooting frame and this IEMBG are seamlessly integrated. Then use one of its built-in ones. Features of documentation. It's kind of like having a GI interface. External interface, we can directly select the file, then get the speed result directly, direct save. So I passed the GPT of this fork. It took me 3 minutes to write the code. Then it took 3 minutes to paste the code, install dependencies, then execute. Take another 3 minutes. I tested the effect of this picture processing, then whether it is 10 in the future, 20 or 100. I can choose the file through this. Instantly select any folder I want, like this one. Then click this to execute. You can get it in a few seconds. Get the picture I want and save. This document, this API interface is the interface I want to operate. So it only took me 10 minutes. I get the result I want. Can improve me 10 times, 100 times the processing. If you have a Python project similar to this, you can also refer to this method. Add a GPT to give you the code. then refer to this method of stable deflation. Using the local external local HTTP method, we cheat docs for this framework using the FastAPI API for documentation with the way to try it in the document. To process this file, everything is local. No need to go through the network. Then the old rules. Show your face. At that time, it will be used as the cover of this cover.